All right, good morning. Let's go ahead and start with Explorer number 2 of the structure of the periodic table. We'll start with our lines. And I'm writing this on Thursday, November 2nd. Okay, and we'll leave a good amount of space here. And we'll go ahead and write down the essential question: how are the columns of the periodic table organized and what do the elements in each group have in common? Question mark. Okay, so let's go ahead and start first with the first main idea: groups or families. That's our first topic, Roman numeral 1. Groups or families. Those are synonyms on the periodic table. Okay, and according to the International Union of Applied Chemists, you have 18 groups. There are 18 groups, aka families. These are the vertical columns. Okay, I'm gonna just write down here, or get our pen, aka, right? That's groups also known as families. You also have your horizontal rows, which are your periods. Okay, so let's just write that down as well. B, you have 7 periods. They are horizontal. Okay. You also have on the bottom, located at the bottom of the periodic table. I'll just put periodic table. Okay, that's PT. We'll put down PT. Okay, so you guys know that's what we refer to as the periodic table. You have the lanthanide series and you have the actinide series. Okay, are 2 additional rows. You have the lanthanide series. These are your rare earth metals. Not because they're so rare, they're just hard to tease out from their surrounding minerals that they're embedded in. And then you have your actinide, which are almost your lab-grown, man-made ones. Actinide series. Okay, and both of these are going to usually have electrons that fill the f orbital. Okay, which we haven't really filled out necessarily in our exercises. And then how would we want to say these? These both are embedded. They're embedded within the transition metals. And the transition metals are groups 3 through 12. Okay, what we would call in US terminology the B group elements, aka the B groups elements, right? If you're talking about the American nomenclature. All right, so moving on here. And then there is a repeat. Sometimes that happens. So we're going to jump right into our alkali metals right now. Okay, so let's talk about letter C here. Alkali metals. Okay. They have a single valence electron. They are going to be found in your first group, okay, group 1. They tend to lose their electron, especially reacting. They react easily with group 17. And what else can we say here? Let's go ahead and clear this. Well, let's just first write those down, okay, some of these points. Makeup. Group number 1, okay, they have 1 valence electron, which they tend to lose. They easily react with group 17 elements. Because group 17 elements have 7 valence electrons, they would like to have 8, so they want 1. And your group 1 elements, they would more easily give up their 1 electron and drop an energy level, thereby achieving a stable valence. So they work hand in hand with each other. Clearing our screen here. Oh my goodness, clear screen. Alkali metals also quickly combine with oxygen. They vigorously react with water, forming strong bases. Okay, so these are probably some good things that we want to write down, characteristics as well, okay? Number 3, we can say that they react with oxygen, they oxidize, and water, they oxidize. And when they react with water, they form bases. Hence the word alkaline. Okay, that's why we call them alkali. All right, group number 2. And again, we're talking about, if I were to actually throw up the periodic table here, we just got through talking about the alkali metals. See that? They're in group number 1. Now we're going to move over to the alkaline earth metals. See how that's highlighted yellow? That's your group 2, okay? So letter D. And let's make sure we carry our lines down here as well, okay? These are going to be your group 2. They contain 2 valence electrons, of course. 2 valence electrons, right? Therefore, they're fairly reactive. Okay. Often losing the electrons in chemical reactions. Okay. Um, uh, Paragraph 2, they kind of talk about them being predictable. They form weak bases. They tend to display distinct colors. So they kind of just describe some things. They tend to form oxides. They tend to have high melting points. They tend to exist in very hot environments. So in the, the paragraphs here, general characteristics and behaviors, I would suggest that you read that, okay? Watch the videos. Let's move on to group number 17, okay? Letter E. These are the halogens. This is going to be group 17. And if you look on the periodic table, there we are. The halogens, well, actually, the halogens are going to be group number 17. And you can see me kind of drawing a circle around group number 17, your halogens, okay? So let's see here. Include 5 non-metallic elements. Okay. Located to the right side. They are very reactive, but not because they have one to give away. They actually have 7, so all they need is one more electron. Um, they have 7 valence electrons, therefore very reactive, right? They just need to gain one electron. So they would typically become negative ions in that process, what we would call an anion. Since elements from group 1 contain 1 valence electrons, halogens easily bond. Okay, very active, especially with group 1. Okay. Halogens, you can see here, what does the word mean? It means salt former. This refers to the fact that when halogens react with metals, salts are produced. Okay. Okay. Number 4, they are salt forming with chemical reactions. Okay. And if you kind of go down and read through the following paragraphs, they're going to give you some general descriptions. This is an interesting point. This is the only group that includes elements commonly found in each of the 3 states of matter. That might be worth noting. Okay. Okay, noble gases. This is moving on to letter F. Letter F, the noble gases. This is going to be your group 18. Okay, they have a full set of valence electrons, full valence electrons. Therefore, they are very stable, aka non-reactive. Non-reactive. Okay. They can react, but only under like very rare circumstances. Okay. So again, if we're using our pen, we're talking about 18 here. They are stable. They are unreactive. Okay. Remember that they hold 8 valence electrons except for the first shell. Um, Everybody in period 1, your hydrogen and your helium, they can take a maximum of 2 electrons and have a full valence. Okay. Let's see here. This is an interesting point too, because they do not bond with other elements. They typically appear as monoatomic elements. Um, Typically, they're just bonded to each other. Um, in like gas type of diatomic molecules or things like that. Okay, there our screen, and let's continue to move on here. And what do we have next? We have the transition metals. Okay, so this is going to be everything in the middle. So if you take a look at rows 3 through 12, those are your transition metals. Okay, you can kind of see I've highlighted that. Okay, these are a little trickier. It's a little harder to predict things with these because not only are the valence shell electrons involved in chemical reactions, but the inner shell electrons can also be involved in that. So this is going to be letter G. Okay, and we're now talking about the transition metals. And these are going to be groups 2 through 12. Okay, they're found in the middle of the groups 3 through 12. They're found in the middle block of the periodic table. Um, like all metals, they're ductile, they're malleable, they're conductive. Some can produce a magnetic field. So we could say that they behave similarly to other metals, but they may have some differences. Okay. Um, Now, here's the part that I want to draw your attention to. The atomic structure of the transition metals allows not only electrons from the valence shell, but also from the next inner shell to participate in bonding. And this is what makes it more difficult to predict an element's properties. Okay, so let's just write that down. Number 3, the bonding can occur with both the valence electrons as well as the next inner shell. Okay, and that's like what they said, makes it a little bit more unpredictable. I'm going to go ahead and hit pause on this, and we'll resume this in just a second. Okay. Okay, moving on to letter H here, the lanthanide series. Remember, we said these include your rare earth metals. Okay. We could say AKA rare earth metals. And again, we said not because they're rare. They're fairly abundant, actually. They are used in a lot of your electronics and things today. If we take a look on the periodic table, you can see that the rare earth, I'm going to highlight this here. There they are. They're brown. They make up period number 6, that horizontal row. And these are what we call embedded within your transition metals. Okay. So let's write down a few facts there. Number 1, period 6. Period 6 elements. Okay. Common in nature, but difficult to isolate. Okay. These are also known, if you take a look here, as the inner transition metals. Okay. Okay. These are difficult. It is difficult to isolate in their pure forms. And that's why they call them lanthanide is a Greek word to hide, to be hidden. Okay. And let's move on here to the bottom here, where we're going to talk about the man-made elements. At the very bottom here, the actinide. This is going to be letter I. And if we take a look here at a periodic table, you can see that the actinide, if I kind of highlight that, they're at the very bottom, row number 7 in that rose color. Okay. Row or period number 7. Okay, so they have 7 electron orbitals. These are man-made. Man-made in a laboratory, right? They are unstable, or most of them are. And these two are embedded within your transition metals, okay? We could say that for both of these. So maybe we should just go ahead and take this and we'll say both are inner transition metals. Okay, they're both embedded in group numbers 3 through 12. Okay. Embedded within group numbers 3 through 12. Okay. And let's see, have we basically addressed all those? I think we have. So your job, of course, is to get comfortable with this stuff, do your reading, okay? But basically, our goal here was to just explain in broad strokes your metals, nonmetals, your metalloids, and then we broke them down into their actual subgroups: alkaline metals, alkaline earth metals, right? See, alkaline metals, alkaline earth, the lanthanides or the rare earths, the actinoids, your transition metals, your what they call post-transition metals. Your metalloids produce that jagged line separating metals from nonmetals. Here's your nonmetal group. You have your reactive nonmetals, and then you have your noble gases, which we'd have to scoot that way. These are your noble gases. So reactive, noble, all that together are your nonmetals. All right, hopefully that helps, and we'll talk to you soon.